video, let's see the chapter 5 continuity and differentiation, class 12, chapter 5, exercise 5.1, 15th question, 26, 27 and 29th. And first is 15th one. So we have to discuss the continuity of the function, where function is defined by f of x is equal to 2x if x is less than 0, 0 if 0 less than x less than 1, 4x if x is greater than 1. Still now we have discussed a function where there will be a condition given whether less than a point or greater than that point or equal to that point, but we have here 2 points. Okay, first let's see, here we need 5 cases. First case 1 is for all x less than 0, the function is 2x, right? We can see it is a polynomial function, right? So therefore the function is continuous. The function is continuous for all x less than 0. Okay, and in the case 2 we'll see for all 0 less than x less than 1, the function here is 0. Function is equal to 0. We are not taking equal. Okay, so we can see it is a constant function whenever x is less than 0 and less than 1. Okay, so whenever x is greater than 0 and less than 1, the function is 0. We can see it is a constant function. Okay, constant function, and therefore function is continuous. Function is continuous for all x 0 less than x less than 1. And the third case is greater than 1. Okay, the third case 3. Okay, case 3 for all x greater than 1, the function is 4x, right? So we can see it is a polynomial function. So therefore function is continuous for all x greater than 1, that is from 1 to infinity. Okay, and the case 4 we are saying at x is equal to 0. At x is equal to 0, the function is 0, right? So first f of x is 0, f of 0 is 0, and left hand limit, that is limit x tending to 0 from left hand, that is whenever x is less than 0, right? So if it is less than 0, the function is 2x. 2 into 0 is 0. And now is right hand limit. The limit x tending to 0 from the right hand side. The limit here is, function here is 0. So we can see right hand limit is equal to left hand limit. Therefore the function exists. And also left hand limit is equal to right hand limit, which is equal to function at that point. So the function is continuous at x is equal to 0. Next is the case 5 is at x is equal to 1. The function is 0. The function at 1 is equal to 0. Left hand limit is the limit x tending to 1 from the left hand side. It should be less than 1. The function is 0, so it is 0. Right hand limit is limit x tending to 1 from the right hand side. The function is 4x. 4 into 1 is 4. We can clearly see that the left hand limit is not equal to the right hand limit. Therefore the function does not exist. Therefore function is discontinuous at x is equal to 1. So from case 1, case 2, case 3, case 4 and case 5, we can conclude that function is continuous everywhere except at x is equal to 1. Everywhere the function is continuous, but at the point of 1, the function is discontinuous. Given that, find the value of k so that the function f is continuous at the indicating point. They have told that the function is already continuous at the indicated point. That indicates that left hand limit is equal to right hand limit, which is equal to function at the particular point. Okay, so let me just explain this. Function is k cos x by pi minus 2x if x is not equal to pi by 2, 3 if x is equal to pi by 2. That they are telling that the limit x tending to pi by 2, function f of x is k cos x by pi minus 2x. So this is the left hand limit and the right hand limit. They are telling which is not equal to, it is a well defined one. And function at a point, that is function at pi by 2, is same. This is, we are telling function is continuous. Function is continuous. Therefore, left hand limit is equal to right hand limit is equal to function of f of a, where x tend to a. Okay, function is continuous at x tending to a. Left hand limit is equal to right hand limit is equal to function at a. Therefore, this one we have to write limit x tending to pi by 2, k cos x by pi minus 2x is equal to f of pi by 2. Okay, if we substitute pi by 2 value, k cos pi by 2. Cos pi by 2 is cos 90. Cos 90 is 0. And pi minus 2 into pi by 2. 2 cancels and this is 3. We get 0 by 0 form. It is indeterminate form. Yes, right. So instead of doing this, we'll write limit x tending to pi by 2, k cos x by pi minus 2x is equal to f of pi by 2 is 3. Okay, the function at pi by 2 is 3. Okay, so we know that sine 90 minus theta is equal to cos theta. I hope you remember the allied angles which was taught in the first PU, okay, in your classes. And this is a formula we are going to use here. And one more is limit x tending to 0 sine x by x is equal to 1. This is sandwich theorem. Okay, and okay, sine 90 minus theta is cos theta. So we'll write this cos x in the form of sine. That is limit x tending to pi by 2, k sine pi by 2 minus x. Theta is x here and 90 can be written as pi by 2 by pi minus 2x is equal to, k is a constant, so we take it out. Limit x tending to pi by 2, and in the denominator we'll take out 2 common. Remainder will be pi by 2 minus x, right? And 2 is also constant, we'll take it out. K by 2 limit x tending to pi by 2 sine pi by 2 minus x divided by pi by 2 minus x is equal to 3. We can compare this to form sine x by x, sine pi by 2 minus x, pi by 2 minus x. But one we are lagging is x tending to 0 we have to get. So if we take x on the other side, we'll get pi by 2 minus x tending to 0 sine pi by 2 minus x divided by pi by 2 minus x is equal to 0. According to sandwich theorem, this whole will become 1. So k by 2 into 1 is equal to 3. K is equal to 3 into 2. 3 into 2 is 6. The value of k is 6.